Welcome to Pristine Maths Club. Like, comment, and subscribe. We shall be looking at loci. Locus 1. The locus of point equidistant from a fixed point. This gives a circle. Let us have a point A there. The locus of a point equidistant from A now. We can take any radius. So we give us a circle. Okay. And we can also decide to take a locus 4 centimeter from a point A. Okay, that gives us a radius of 4 centimeter. Okay, we can now have the circle now. That will be from 4 centimeter from A. Okay, so anywhere we put x there, it will be 4 centimeter from point A, and that's our locus. Example: the locus of a dog tethered to a pole with a rope of 4 meter is, okay, if we have the locus from a fixed point, you should know that it's a circle. Okay, this is a pole now. We have the dog there. The rope is 4 meter. It's used to tie the dog to the pole. Okay, so we can see that the dog can only move around within that circle. So the answer should be a circle with radius 4 centimeter. Circle with a radius what? 4 centimeter. And that is about that. Let's look at another example. What is the locus of the midpoint of a chord of length 6 centimeter with a circle of radius 5 centimeter and with center O? Okay, the locus of the midpoint of a chord. Anytime you see the locus from a point, then you should know that it's a circle. Locus from a point is always a circle. So B can never be the answer because it's perpendicular, and C also as well can never be the answer. This is how you filter your answer in exam. Now to do this, we have a radius of 5 centimeter. So we have a circle there to be 5 centimeter. Okay, and the next thing now is that after getting our circle, we have the chord to be 6 centimeters we have been given. Okay, if we have the chord to be 6 centimeter, we join the midpoint of the circle to the tip of the chord, which is also 5 centimeter. That is our radius. Okay, by using Pythagoras, it gives you right angle triangle. The midpoint of the circle to the midpoint of the chord is 4 centimeter by using Pythagoras rule. So you now have hypotenuse 5, the other two sides 4 and 3. So now we are to get the locus of the midpoint of the chord from the center of the circle. Gives a circle of radius 4 meter. Option A. Okay, let us look at another way this could be asked. The locus of a point X which moves on one side of a straight line AB so that the angle AXB is always equals to 90 degrees is a semicircle. We have a line AB, the straight line AB of I think 6 centimeter. Okay, and that's the diameter. So we have our semicircle in this case, and we'll see the line AB there. So from the 2 point AB to any of the circumference, the angle that is made there is always 90 degree. So the X could be at any point in the circumference. The angle for AXB will be 90 degree, which is constant. Okay, that is for that. Anywhere you put X there, it will give you AXB to be 90 degree. The angle that the x made is 90 degree. Okay, let us look at another instance. When x moves on both sides of a straight line AB, which is the diameter, the locus is a circle. Okay, so in this case, the same thing we have to do, only that the locus is on the two sides of a straight line AB, which is the diameter. So whichever way we put our x there in both sides, it will still be AXB equals to 90 degree. Okay, what is the locus of a point P which moves on one side of a straight line XY so that the angle XPY is always equals to 90? This is a semicircle. Option D is our answer. We just did it now. If U and V are two distinct points and W is a variable point such that UWV is a right angle, what's the locus of a point W? Okay, the same way we have the UV is a straight line, which is the diameter in this case. Okay, and you have your W can be any part of the circumference. Since they didn't say it's just on one side, so it's on both sides. So you have a circle such that UWV is always 90 degrees. So it's a circle with line UV as diameter. That is option D. Okay. Let us look at the locus too. The locus of a point equidistant from 2 points A and B is a perpendicular bisector of the line AB. The locus of point equidistance from two fixed points is usually the bisector. We have a line AB. We bisect AB into two equal parts. So as we can see there, so we also put the compass on the point B as well. Then we have the arc as well for the up and down. So we'll now have a straight line. Okay, so we have a straight line that divides the AB into two equal parts. Okay, so let's say a point X is there. Okay, the distance from A to X is AX. We can have it there, and we can also say the B to X also, the distance also BX, and the two distances are the same thing. That's the purpose of being a locus. They will be of the same distance. Well, anything is on the locus, it will be of the same distance to the 2 point that's is a locus to. So AX now is equals to the BX. Okay, the same way also, suppose we say that K is our midpoint in this case, that is the locus, divide the AB into two equal parts. So we'll say that AK is also equals to BK. Let's look at an example on this. The locus of a point equidistant from two given fixed points is the of course we should know that it's the perpendicular bisector of the line joining them. Option A is our answer. Okay, let's look at another example. The locus of a point equidistant from two fixed points P and R, of course, a perpendicular bisector of PR passing through the midpoint. Or let's say AB is a line and has a coordinate x1, y1, and B also has a coordinate x2, y2. Okay, so to do this, we are looking for the midpoint of AB, and the midpoint of AB, let's say, is M. Is usually given as x1 plus x2 over 2 comma y1 plus y2 over 2. Okay, that's the coordinate of the midpoint of AB. Okay, so now we have P to be 6 comma 2 and our R to be 4 comma 2 as well. To get the coordinate of this, let's say we have the M, which is x1 plus x2 or over 2 common the y1 plus y2 over 2. Of course, we should know that that is x1 y1 x2 y2. We plug in all these values into the formula then. So we are going to get 6 plus 4 over 2, and the next one we are going to get 2 plus 2 over 2. Okay, so the coordinate will now be 6 plus 4, that is 10 over 2. So to give us 5, okay, and that one will give us 2. And that should be the option B for our answer now. Okay, let's look at another example. If the locus of the point P and Q meets line PQ at point N, then Pn equals to we have a PQ here. We have the locus that divide it into two equal parts and meet line PQ at N. So we know that Pn is equals to NQ. So it shows that Pn is equals to half PQ, which is also equals to the NQ in this instance. Okay, option D is our final answer. And let's look at this example. What is the locus of point that is equidistant from point P and Q? Okay, to solve this, we have to know that we are given the 2 points, and the equidistance will be the midpoint. Any line that will divide the 2 points will be in the midpoint of the 2 point P and Q. So let our A, having a coordinate of x, y, be the midpoint of the line P and Q. I think we can say there. So, and our P is there, the Q is there. Okay. The AP is equals to the AQ. That is, they are equal, and square of the AP is also equals to square of the AQ. That is, this implies that. Okay, so when they are equal, when you square them, is the same thing. So we have to recall the formula. The distance between the 2 points A and B, A having a coordinate x1 y1, B coordinate x2 y2, is equals to distance AB is equals to, we open the bracket, the x2 minus x1, we square it, plus y2 minus y1, and we square it as well. Okay, so having known this, we will apply this one here for the line AP as well. So the distance between line AP now will now be, of course, we know that P has a coordinate of 1, 3, and Q a coordinate of 3, 5, and our A has a coordinate of x, y. Okay, so we'll say that the distance AP will be that the x coordinates of A minus the x coordinate of P. So you have x minus 1. We square it according to the formula there. We square it plus y2, the coordinates y of the A, minus 3. We square it as well. We do the same thing. We won't have the square root because AP has a square already. We do the same thing for AQ, which is x minus 3 square plus y minus 5 minus y square. Anyhow, we can even use y minus 5 everything square. Once it's a square, it will give us the same thing. Arrangement doesn't matter in that instance, even though I will change it. So to do this, we say x square minus 2x plus 1. We expand it. Y square minus 2 times minus 3 times y, so minus 6y plus minus 3 square give you 9. Plus we expand that one as well. We have x square minus that's 6x plus 9. You should know how to expand that. We equals to, let me change this one now to have a y minus y minus 5 as well. Okay, so we now have y square minus 10y, okay, plus 25. Okay, we collect like times. Of course, we know that the x square will cancel the x square. The x square minus x square will give us 0. The same thing y square and y square on the other side. And of course, even I'm seeing 9 there will cancel each other. So we can now see that if minus 10y come to the other side there, we have it will become plus 10y. Plus 10y minus 6y give us plus 4y equals to when the minus 2x go to the other side, it become minus 6x plus 2x, which will give us minus 4x, of course. And this is 25 now, minus 1 in that side. Since the 9 will cancel 9 there, so it will give us plus 24. Yeah, it's going to give us plus 24, and we divide everything by 4. So we'll say that y is equals to minus x plus 6. Okay, this becomes the option B for answer. Do not forget to subscribe to my channel for more content. Thanks.